your tangent. But sometimes you're just not quite satisfied enough with just the slope, and you want to find the whole equation of that tangent line. So we get to review grade 10 math of finding an equation of a line. Do you remember y equals mx plus b, right? Or, here, do you remember the point slope form of the equation? I'm going to add, do you remember that one? I find lots of students don't remember that one. Y minus y1 equals mx minus x1. You're shaking your head. Some of you don't remember it. Do you remember that slope is rise over run? Okay? So if slope is rise over run, and rise is your difference in your y values, this is your slope formula. You might remember that. If you take your slope formula and you just make one of them y and one of them x, and multiply to get rid of the fraction, you get that equation. So now that you see that, it might be easier to remember the point slope formula, because it's like, oh, it's just my slope formula rearranged. And it just has one x and one y, because when you write an equation of a line, you need one x and you need one y. So you only need one point and the slope to figure it out. But to get the equation of the tangent line, you could also use y equals mx plus b. So we're going to see how this works. We've got a parabola. I'm going to draw a picture of this so we can visualize it. Would you agree that the vertex is at 0, 3? That if the parabola is opening up, it would go over 1, up 2. So you'd have 1, 5, negative 1, 5. Because there would have been a vertical stretch. You could plug in values to get other points if you wanted to. Then at 1, 5, they're saying, hey, let's find, there's a tangent line there, that's right there. We could use calculus to find its slope, but we want you now to find the exact equation. So how do we do that? Well, this is something straight from grade 10. There are two things that you need to find an equation of a line. You need the slope, and you need a point. We can get the slope now from calculus. The derivative of 2x squared plus 3 would be 4x. At x equals 1, the derivative would be 4. So we now know that in our equation, m has to be 4. Now, I cheated a little bit because I graphed it already, but the point had to be 1 comma something, because we're finding the derivative at x equals 1. The reason I said I cheated is when I graphed it, I accidentally found the y coordinate really easily. But it's not hard to find a y coordinate of a point. If x is 1, what could you do? You could plug in 1 into the equation and easily find out that that point was 1 comma 5. Once you have the slope and the point, you have two options to find the equation. Some students, here I'll split my page up here, I'll say, I'm going to say option 1, y equals mx plus b, and option 2 would be y minus y1 equals m x minus x1. Because typically, you remember y equals mx plus b quicker than you remember point slope for. So it is something generally people go to more often. Right? Next year, you're in university, you're helping your friend who's taking first year calculus. They're in this question. When you mention these options, they're like, I remember y equals mx plus b. Then you say, okay, we'll go to option 1. If you have option 1, what do you know already? You know the slope is 4. So this is how far you're at, but you don't know the y-intercept. But because you know a point, you can plug in that point 1, 5. You know that when y is 5, x is 1. And then it's not hard to solve for b. Once you have your slope and you have your y-intercept, you have your equation. The nice thing about the slope point formula is right away you can plug in your slope and your point. So you have y minus, oops, the y coordinate is 5, equals the slope is 4. So where the x1 and the y1 are, that's where I plug in my point. Where the m is, that's where I plug in my slope. And so I would have y minus 5 equals 4. If I distribute x minus 4. If I wanted to rearrange this to get y by itself, I could add 5 to both sides. And now I've got the same equation on both sides. So I now know, going back to my picture, that this line right here, not only does it have a slope of 4, perfectly drawn, it went through my y-intercept of 1 so nicely. Okay, my first drawing was not to scale, but that is what we could figure out. Now we know that equation exactly. And this is a little review of grade 10 math. My grade 10s are just starting lines now. How many of you learnt lines during the first start of COVID? Were you in grade 10 when COVID hit? Grade 9. So then second year of COVID would have been grade 10. Okay. Oh, I like this one. I like this one because it's not the one that's your example too. Uh-oh. Is it different? Yeah, because this one's harder. Shoot. Okay. Yours says, what does yours say? Square root of x to the 5? Can I change? I'll do yours so it matches up with your notes. Because your original one said the square root of x to the 5. What kind of makes the one that I have a little bit trickier is the one that I have, we don't have a rule yet to be able to do it with a shortcut. So we would have had to use the definition of the derivative. And as your faces are like, oh, we're going to do 15 minutes of work. I saw that you were so excited. So we'll go, the other one though, that you have can be done with a shortcut. Can you see that you can find the derivative really easily? Bring the 5 halves out in front, subtract 1 from the exponent. And now Now we have some mental math to do. Plug in 4. How's it looking? Oh, I feel like making up math. I feel like math that would be good to make up is like, I think my 2's should cancel out. I don't know what to do with the 3, so I'm going to ignore it. That just leaves a 5 and a 4. 5 times 4 is 20. And that is the right answer, but not the right way to do it. Yeah? It's good math?
I would have added 3 back on.
Yeah, but then it doesn't work. You type this into your calculator, you'll get 20. How would you do it with real math? This is the part that's hard. Okay? If you have this, I would do the half first. What's the half? Half is a square root. All of a sudden, can you see that that's 8? And then if I put an 8 here, 5 times 8 divided by 2 is 20. I kind of like mine. Just cancel out the 2's, ignore the 3. 5 times 4 is 20. Okay? So now we have our slope. We need a point. Well, it's going to be at x equals 4, so it's going to be 4 comma something. What would happen if you plug 4 in to x to the 5 halves? I would do the square root first, which would give you 2. 2 to the 5. 4 comma 32. And now you can choose either y equals mx plus b or the point slope form. If you use y equals mx plus b, you plug in 32 for y, 20 for the slope, 4 for x. Subtract the 80 on both sides. And b would equal negative 48. So your equation then, y is equal to 20x minus 48. If you wanted to use your point slope formula, y minus y1 equals slope x minus x1.
I'll just come see you in a second.
Okay. If it's about the question, I haven't done it yet. I got home and I got busy. Yeah, I put the videos up on the So this would become y minus 32 equals 20x minus 80. And if you add your like terms together, you get the exact same equation. Good? Now I have to be careful. Make sure that the equations match up. So it says make a sketch. Often, that's a very good thing to do at the beginning. Y equals 2x squared. Can you see that that's a parabola with vertex at 0? Go. Plug in 1. So you can plug in a couple points. And then it says the two tangents to the curve at the points where y is 8. Ooh, how handy was that I already had those 2 points. I'll highlight them in blue. And this one would make this tangent, and this one would make that tangent. Can you see that they will eventually cross each other? That's what we have to find. Where do they cross each other? So, big idea. We could find the equation of this tangent line, and it will be y equals mx plus b. And then we could find the equation of the other tangent line, and it will be y equals mx plus b. And how do you find where two lines cross? I gave you just two random lines. Where do they cross? How do you find that? You could use a graphing calculator. If it was a calculator question, very quick. Type this one into y1, this one into y2. Where do they cross? Boom. Solved it. Good. If it's not a graphing calculator question, it's a systems of equations question. Right? Where you could, right? Oh, y, I could substitute. I make 3x plus 5 equal to negative 2x plus 7. Solve for x. Once I get x, plug it in, solve for y. So sometimes it's important before you start doing too much with a question to think about how you would solve that question. Oh yeah, life just got crazy in the soccer game. Argentina was winning 2-0. It's 2-2. With Argentina scored in the 12th minute of extra time in the game. No, Netherlands to tie it. Like, Argentina was literally minus 2 minutes away from winning. Past, they said it'll end at 10 minutes extra. It was already 12 minutes extra. And they scored. Unbelievable. So crazy. I don't know if I can do this question. All right. So, if we look at the first one, we're going to need to find our derivative. That's super easy. And if you plug in this point, can you see that the slope of this line will be negative 8, and the slope of this line will be positive 8. Really easy to do, we just have to plug in x. So that was nice. I'm going to put a little number 1 here for line number 1 and a little number 2 here for line number 2. Equation of line number 1, using y equals mx plus b, I could plug in 8 for y. The slope is negative 8. X is negative 2 plus b. Multiply things out. B would be negative 8. And so equation number 1 is y equals negative 8x minus 8. Equation number 2, the y value is 8. The slope is positive 8. The x value is positive 2 plus b. So I plugged in my slope, I plugged in my point. I can solve for b and I get negative 8. So equation number 2 is y equals 8x minus 8. Now normally you would have to solve a systems of equations unless you notice a shortcut. What is the shortcut that allows you to say point P right away? Where do these two intersect? -8. They have the same y-intercept. So it's kind of cheating. Well, not cheating, but good observation that they have the same y-intercept. So we could solve this one just by observation. But otherwise, you might have had to use a systems of equation to figure it out. Okay. Someone's probably phoning me about the soccer game being crazy. I'm pretty sure that's what it is about. Hmm. Ooh. Can you visualize that graph? Sort of, from grade 12 pre-calculus. It would be an x cubed graph with n behavior like that. Somewhere on this graph, x is equal to 4. Right? And is it, yeah, at 4, -21, it tells us. Somewhere on the graph we have 4, -21. And we have a tangent. But it's also saying that somewhere else there's another one that's parallel to it. Okay, that's a little crazy. But drawing the picture can help you understand what the question is asking. So what could we find? Does it make sense that we could probably find the slope of this line? We could find that with calculus because we can find the derivative. The derivative in this case would be 3x squared minus 6x minus 13. And at x equals 4, and this is why this notation is really nice, because you can write in function notation, the derivative at x equals 4 is equal to 3x squared minus 6x minus 13. Well, we plug in 4, you'll get 3 times 16 minus 24 minus 13. Someone double check my mental math just to make sure. You get 11. So we now know the slope of this tangent line is 11. How do we find another equation that would do that same thing? So we need another x point where the slope is 11. So if we think about the big picture of what we found, right? This is the formula for all slopes. We are looking for the x values where the slope is 11. So what we can do in that equation is we could plug in 11 for the slope. That would give me 11 equals 3x squared minus 6x minus 13. A quadratic equation. How do you solve quadratic equations? You make one side equal to 0. 0 equals 3x squared minus 6x. Move the 11 over, minus 24. Can you see that you could divide everything by 3? So if I divide everything by 3, I would just get x squared minus 2x minus 8. And as far as factoring goes, you already know what one of the factors has to be. Because the slope was 11 when x was 4, you know that one of these has to be x minus 4. So that actually makes your multiplication easier, because the only other thing that would give you the minus 8 would be a plus 2. And so you'd have x equals 4 and x equals minus 2. And now we know this much information. We know that this other line still has a slope of 11. We know that the x coordinate is minus 2. And we still want to find the equation of that second line. So what are the two things you need for an equation of a line? You need a point and a slope. We've got the slope already. We've almost got the point. Any idea how to find the y coordinate of that point? Would you agree that that point is on the blue graph? You have the equation of the blue graph. So you could just plug in minus 2 into the equation of your blue graph, right? Be minus 2 cubed minus 3 times minus 2 squared minus 13 times minus 2 plus 15. So minus 8 minus 12 plus 26 plus 15. You get positive 21. If you're using y equals mx plus b, we now know that our slope is 11. The x value is minus 2. The y value is 21. We want to find b. Add 22 to both sides. We get 43 for b. So that equation would be y equals 11x plus 43. One thing that'll start to happen in IB classes, okay? You might feel like 43 is kind of like, ooh, I haven't seen a 43 for a while. It feels a little weird. Perfectly normal to have weird numbers in an IB question. It would not be uncommon if the final answer to this was y equals 11x plus 87 over 13. And you would write 87 over 13, and your training up until now has told you, I must have made a mistake, because that number, my teacher wouldn't make a number looking like that to me. But it will happen, that you will get odd-looking numbers in IB questions. But the good thing is we will do lots of take-home quizzes and different activities where you see lots of weird numbers, so you get used to weird-looking numbers. Okay, I want you to try, this is a problem-solving one, try it on your own. I will find the answer and put it up shortly.
Yeah, right.
And then when you find,
Did you get the derivative right?
How did they play? K has to be something.
There we go. So this question is very typical, like a normal question. You would get the equation, find the equation of a tangent at a certain point, and you do things. this question, they gave you like the answer. They gave you the tangent, and you sort of have to work backwards. So the first working backwards is from the tangent line, you could steal the slope. Agreed? And if you stole that slope, you could plug it into the derivative and find out that x had to be 2. So then the value of p is 2. There's a little picture of it. Then, to find k, you know that this point when x is 2 is on this line. And it's also on this line. So if you plug 2 into y equals 7x minus 9, you find out that the point is 2, 5. Then you could plug 2 and 5 into the original equation and solve that k has to be equal to 3. So this is typical that they take a standard question and switch things around, so you have to solve it in a different way.